You're listening to AI Signals Daily Dose. At GTC 2026, NVIDIA announced NemoClaw, an open source stack that adds enterprise security and sandboxing to OpenClaw, the popular open source AI agent. It pairs with NVIDIA's DGX hardware line to let organizations run autonomous agents locally with proper isolation and policy controls. Today, we're going to unpack what NemoClaw actually is, what it means for organizations that want to deploy AI agents safely, and how NVIDIA is using it to position itself at the center of the agent infrastructure layer. This is your daily dose. To understand why NemoClaw matters, you need to understand the problem it solves. OpenClaw is an open-source AI agent with over 214,000 GitHub stars. You can host it on your own hardware, and it handles real tasks. It manages files, runs shell commands, browses the web, sends emails. It connects through WhatsApp or Telegram, and the community around it has been growing rapidly. Peter Steinberger, the original creator, joined OpenAI earlier this year, and the project is now maintained by an open-source foundation. The issue is that OpenClaw, like most open-source agent frameworks, runs with broad system access and minimal isolation. When an agent can execute code, access credentials, and make network requests on your behalf, the security surface is large. For individual developers, that's a manageable trade-off. But for organizations in regulated industries, healthcare, finance, government, deploying an agent without sandboxing, audit controls, and data residency guarantees simply isn't viable. That's the gap NemoClaw addresses. At the core of NemoClaw is OpenShell, an open-source runtime that sits between the agent and the host system. OpenShell provides kernel-level isolation, meaning the agent runs inside a sandbox that is walled off from the rest of the operating system by default. File access, network access, and process creation are all denied unless explicitly permitted. The way you configure permissions is through declarative YAML policies. You define exactly what the agent can read, write, and connect to, and everything else is blocked. This deny by default model is familiar to anyone who's worked with container security or network firewalls, and it's the right foundation for running autonomous software. Credential handling is also built in. Secrets are never written to the sandbox file system. Instead, they're injected as environment variables at runtime and removed when the session ends. This means even if the agent's sandbox is compromised, credentials don't persist in a place where they can be extracted. One of the more thoughtful design decisions is the privacy router. When the agent needs to call a model for inference, the router evaluates the request and decides whether to run it locally on the host GPU or send it to a cloud endpoint. Sensitive queries, anything involving proprietary data, personal information, or regulated content, stay on local hardware. Routine requests can go to whichever model provides the best result. For organizations that need to comply with data residency requirements, this is a meaningful capability, not a checkbox feature. The full NemoClaw stack bundles three components. First, the OpenShell runtime I just described. Second, a reference architecture called AIQ, which is a research agent blueprint that shows how to structure long-running agents with tool use, planning, and verification steps. And third, NVIDIA's Nemotron family of open-weight models. The lead model here is Nemotron 3 Super, a 120 billion parameter mixture of experts architecture that activates only 12 billion parameters per forward pass. It scored over 60% on SWE Bench Verified, which as of today is the highest score among open-weight models on that benchmark. Because of the mixture of experts design, it runs efficiently on a single DGX Spark, which has 128 gigabytes of unified memory on the GB10 superchip. That means an organization can run a capable coding and reasoning model entirely on local hardware, with no cloud dependency for inference. This is the practical value of the stack. You get the security layer, the models, and the reference architecture, all designed to work together on hardware you control. The business logic behind NemoClaw is straightforward. NVIDIA sells hardware. Open source software that creates demand for that hardware is a proven strategy for them. CUDA made NVIDIA GPUs the default platform for deep learning research. Omniverse is doing the same for simulation and digital twins. NemoClaw follows the same pattern for AI agents. Agents are a particularly compute-intensive workload. A single agent session can involve dozens of model inference calls, tool executions, web lookups, and code generation cycles. An organization running hundreds or thousands of agents continuously needs substantial local compute. NVIDIA's pitch is that NemoClaw on a DGX Spark or DGX station gives you a secure, always-on agent platform at your desk, and when a task exceeds local capacity, the agent can scale to cloud resources seamlessly. What makes the GTC announcement more than a product launch is the ecosystem backing. Salesforce, Cisco, Adobe, CrowdStrike, Dell, and Red Hat all announced integrations with the NemoClaw stack. CrowdStrike published a secure-by-design blueprint for deploying enterprise AI agents on OpenShell. Dell is the first manufacturer to ship the GB300 desktop optimized for NemoClaw workloads. These are production commitments, not partnerships in name only. NVIDIA also announced the Nemotron Coalition, a collaboration with Mistral AI, Cursor, LangChain, Perplexity, and Reflection AI to co-develop open frontier models. The first project is a base model being built jointly by Mistral and NVIDIA for the Nemotron 4 family. This positions NVIDIA not just as a hardware vendor, but as a coordinator of open model development, which reinforces the ecosystem lock-in. Stepping back, the broader signal here is about where AI infrastructure competition is moving. For the past 2 years, the main battlegrounds have been model quality and inference cost. NemoClaw represents a shift toward the execution layer, the software that governs how agents actually run, what they can access, and where data flows. If NemoClaw becomes the standard way enterprises deploy AI agents, NVIDIA gains influence well beyond chip sales. They would shape the security model, the deployment patterns, and the model ecosystem that enterprises build on. That's a significant position in a market that's still in its early stages. Whether that happens depends on adoption. The open source licensing helps. The enterprise partner commitments help. And the fact that OpenClaw already has a large developer community gives NemoClaw a ready-made user base. The next few months will show whether this translates into production deployments or remains a conference announcement. That's the picture for today. NVIDIA's NemoClaw gives OpenClaw the enterprise security layer it's been missing: sandboxed execution, policy controls, privacy routing, and a full model stack that runs on local hardware. The ecosystem commitments from CrowdStrike, Dell, Salesforce, and others suggest this is moving toward production. Worth following closely as agent deployment moves from experimentation to real enterprise workloads. I'll be back tomorrow with more. Until then, stay curious.